Hello, everyone, and welcome back to The Explainer. I am absolutely thrilled you're joining me today. If you're the kind of person who loves to get straight to the facts, understand how things actually work, and really grasp the why behind the headlines, well, you are in the exact right place. Today, we're setting the stage for a structured, deeply fascinating dive into the mechanics of the Earth's most devastating phenomena. We're talking about the raw, completely unfiltered forces of nature.
Okay, let's dive into this. When you witness the sheer scale of these events, it's honestly breathtaking. From raging wildfires to massive floods and terrifying seismic shifts, our planet is dynamic, it's chaotic, and it's unimaginably powerful. We so often take the stability of our environment for granted, but these massive shifts remind us of the unpredictable power that surrounds us every single day. To actually survive and adapt to these extreme events, we can't just be afraid of them, we have to logically understand the mechanics driving them.
So here is our roadmap for today. We'll start by defining what makes a natural disaster, then move underground to explore earthquakes. After that, we'll see exactly how scientists measure the devastation, dive into water hazards like tsunamis and cyclones, look at the silent killer of heat waves, and finally, wrap things up with mitigation and early warnings.
First up, defining natural disasters, unpacking the threat. Because to survive the Earth's most extreme processes, we first have to accurately define what we're actually up against. A natural disaster is formally defined as the natural processes of the Earth that cause widespread destruction to the environment and loss of life. But I really want you to focus on those last three words right there, massive scale. It's the staggering, overwhelming magnitude of impact that fundamentally redefines an environment and completely upends human civilization. It's not just a bad storm, it's a massive shift.
Section 2. Earthquakes, shaking the Earth. The ground beneath our feet always feels so permanent, but as we're about to see, it is rarely as solid as we like to believe.
Now, what's really interesting here is how we can clear up one of the most common confusions in geology. When the Earth trembles, that sudden release of energy actually happens deep underground at a very specific point. We call that the focus, or the hypocenter. But those energy waves travel outward, right? The point on the surface directly above that interior rupture is the epicenter. So that surface point, the epicenter, is where the destructive impact of those waves is going to be felt the absolute most.
So what actually pulls the trigger? Well, we have natural factors, of course, massive tectonic plates shifting, faulting, or volcanic activity. But consider the other side of the equation, anthropogenic or human-caused factors. That's right, humans actually play a role in creating earthquakes. Deep underground mining, extensive drilling, blasting rocks with dynamite, and the massive force of nuclear explosion tests can literally disrupt the Earth's crust enough to cause a localized quake. Crazy, right?
Scientists categorize these tremors by their focal depth. We have shallow quakes at less than 60 kilometers deep, and medium ones from 60 to 300 kilometers. But then, we have deep earthquakes. These originate anywhere from 300 to an astonishing 700 kilometers deep. I want you to just slow down for a second and let that sink in. A massive energy rupture happening 700 kilometers beneath the soles of your shoes, violently rippling all the way up to the surface. It is simply mind-boggling.
And this is what it looks like when that energy finally breaches the surface. This grounds our theoretical geology into a very, very grim reality. High-magnitude quakes don't just rattle your windows. They cause the total collapse of entire structures and buildings. The Earth cracks open. Underground pipelines are snapped in half. Railway lines are twisted like wire. A massive tremor fundamentally breaks the very infrastructure that keeps our society functioning.
Section 3. Measuring the devastation. Which naturally leads us to a critical question. When faced with this terrifying damage, how do scientists actually quantify the chaos?
So, the crucial point is understanding the battle of the scales. We basically have two primary ways to measure a quake. Charles Richter gave us the Richter scale back in 1935, which measures magnitude. That's the absolute invisible amount of energy released, scored from 0 to 10. But then you have Giuseppe Mercalli's scale from 1902, the modified Mercalli scale. This one doesn't measure invisible energy at all, it measures intensity. It looks at the visible destructive strength and damage on the ground, using Roman numerals from 1 to 12. Think of it like this. One measures the invisible punch, the other measures the visible bruise.
Section 4. Water hazards, tsunamis, and cyclones. Let's shift our focus now from the shifting Earth to the swelling seas, introducing the devastating power of the ocean when it violently breaches our coastlines.
When a cyclone hits, one of the absolutely most destructive elements is the storm surge. This is an abnormal rise of water generated by a massive storm that pushes over and above the regular predicted tides. You have to think of it as a terrifying force multiplier. If this storm surge happens to coincide with a normal high tide, it creates what's known as a massive storm tide. And the result? Extreme coastal flooding that completely inundates human settlements and agricultural fields.
And if we look at tsunamis, those massive waves usually triggered by the underwater earthquakes we just discussed, the impact isn't just that initial crash of water. It's a devastating domino effect. Yes, the high waves sweep out building foundations and cause tragic drownings, but it's the secondary crises that are so brutal. Damaged ports prevent crucial medical supplies from ever arriving, and you get a massive public health nightmare because broken pipes lead to sewage and saltwater completely contaminating the drinking water supply. Surviving the wave itself is often just the very first test.
Section 5. The silent killer, heat waves. We're going to transition now to a very different, much quieter, but equally dangerous natural disaster. Extreme, sustained spikes in atmospheric temperature.
And this brilliantly illustrates how defining a heat wave actually depends entirely on where you are. On a global level, the World Meteorological Organization defines it as 5 or more consecutive days where the maximum temperature exceeds the average by 5 degrees Celsius. But locally, baselines shift. The India Meteorological Department has very specific thresholds. A heat wave is declared when the maximum temperature reaches at least 40 degrees Celsius in the plains, but in the cooler hilly regions, the threshold is significantly lower, at just 30 degrees Celsius. It's all about what the local environment is fundamentally built to handle.
Section 6. Mitigation and early warnings. I know this is heavy stuff, but let's lift the narrative from the impacts of disaster into a genuinely empowering conclusion, focusing on human resilience, administrative solutions, and cutting-edge technology.
Because listen, we are not helpless. Organizations like the National Disaster Management Authority, or NDMA, actively work to reduce our vulnerability before the storm even hits. Their strategies involve deep community mobilization and training, building specific cyclone risk mitigation infrastructure, and vital collaborations with civil society and NGOs to build temporary shelters. It's all about proactive capacity building. That way, when the environment turns hostile, the community is actually ready for it.
Now let's move to early warnings and see how this builds into a technologically advanced defense. In India, there's a brilliant early warning system run by INCOIS in Hyderabad. This is a UNESCO-accredited center that doesn't just sit around waiting for disaster. They continuously monitor seismic and sea level data using custom-built software applications. Based on preset rules, this system can instantly generate critical tsunami warnings, buying coastal communities the one single resource they need most: time. It is literally a system that saves countless lives.
We've explored the raw power of the Earth, the mechanics of its fury, and the incredible lengths human beings go to measure and mitigate these threats. With early warning systems silently monitoring the Earth and the seas every second of every single day, the ultimate question really isn't if the next massive disaster will strike, but as a society, are we ready to listen? And more importantly, are we ready to act? Thank you so much for joining me on this explainer. Keep learning, stay curious, and stay prepared.